Welcome to the Wattnet dashboard, an interactive, open-access tool that lets you explore the environmental footprint of electricity across Europe in real time. In this walkthrough, we will go through the dashboard's main features step by step. You can follow along by opening dashboard.wattnet.eu in your browser. No account or registration required. When you first open the dashboard, you will see an interactive map of Europe. Each zone is colored according to the currently selected environmental metric. The sidebar on the left is your control panel, and the map takes up the center of the screen. Notice the indicator in the top left corner of the map. This tells you at a glance which mode you are currently in. Live, when showing the most recent available data, historical, when exploring past data, and forecast, when looking ahead. This indicator updates automatically as you navigate through time. Let's go through the sidebar from top to bottom. At the top of the Options section, you will find the Date and Time selector. This controls which moment in time the map is showing. By default, it displays the most recent available data, updated automatically every 15 minutes. You can use the calendar to jump to any specific date. The calendar also allows you to select a range of consecutive days. Simply click a start date and an end date to span multiple days at once. The time slider below then lets you move through that range at 15-minute steps. You can also use the navigation arrows to step forward or backward one interval at a time, or change the playback speed to animate the map automatically, watching Europe's electricity footprint evolve across the day. Below the time controls, you will find the environmental metric selector. You have three options: footprint, impact, and green score. Footprint shows the raw carbon or water footprint per kilowatt hour. Impact goes a step further. It weighs the water footprint against regional and seasonal freshwater scarcity, telling you not just how much water was used, but how ecologically significant that use is, depending on where and when it occurred. You will notice that impact is only available with the water dimension and operational scope. This is because water scarcity impact can only be assessed locally. We know where and when the water was used during electricity generation, which is what matters for ecological stress. Green score combines this water operational impact with the carbon operational footprint into a single 0 to 100 index, where higher means greener. Let's keep footprint selected and look at the environmental dimension below. Here you can switch between carbon and water. With carbon selected, the map shows the CO2 intensity of electricity consumption in grams, CO2 equivalent per kilowatt hour. Switching to water shows the water intensity in liters per kilowatt hour. Let's start with carbon and see how Europe looks right now. You can immediately see the differences across Europe. Northern countries like Norway, Sweden, and Finland consistently show very low carbon intensity. They generate most of their electricity from hydropower and wind. Countries in Central and Eastern Europe that rely more heavily on coal appear in darker orange or brown. The Assessment Scope selector lets you choose between life cycle and operational. Operational only accounts for emissions during the actual generation of electricity. Life cycle goes further. It includes the emissions associated with building, maintaining, and decommissioning power plants. Life cycle is the default and recommended option, as it gives a more complete and honest picture of the true environmental cost of each energy source. Now let's look at one of the most powerful features of Wattnet: flow tracing. With it disabled, the map shows only the local production-based footprint, what each country generates within its own borders. When we enable it, you will notice arrows appearing on the map. These represent the cross-border electricity exchanges between zones, showing the direction and relative magnitude of power flows across the European power grid at this moment. But these arrows are not just decorative. You can click on any of them to see the details of that specific exchange, the amount of power being transferred in megawatts, and crucially, the environmental intensity of that flow. How much carbon or water footprint that electricity is carrying into the destination zone. This is what makes flow tracing so powerful. You can see not just that electricity is moving from one country to another, but what environmental impact it brings with it. A large flow of wind power from the north carries very little carbon intensity. A flow from a coal-heavy power grid carries a much higher footprint, and that gets factored into the consumption-based calculation of the destination zone. Notice how enabling flow tracing changes the values for some countries, particularly those that import significant amounts of electricity from their neighbors. If you hover over any zone on the map, you will see a small tooltip appear showing the current value of the selected metric for that zone at the current timestamp, a quick way to compare zones without leaving the map. If you click on a zone, the zone detail panel opens on the right side of the screen. This gives you a much more complete view, the current value, the timestamp, and additional context about the data. The panel also includes a trend chart, showing how the selected metric has evolved for that zone throughout the day. This is where you can really see the patterns in action. For example, in countries with significant solar generation, you will typically see the carbon footprint drop during the middle of the day when solar output is at its peak, and rise again in the evening as fossil fuel plants compensate for the loss of solar. This daily rhythm is one of the most consistent patterns in the data. Let's use the time animation to see this in action. Press play and watch how the map evolves over the course of a full day. You will see the greener zones shift and change as renewable generation fluctuates, solar peaks during the afternoon, wind varies across regions, and demand patterns change from morning to night. What looks like a static map is actually a constantly moving picture of Europe's electricity system. So far, we have been exploring historical and real-time data, but Wattnet also lets you look ahead. Using the date and time selector, you can navigate up to 72 hours into the future to see the forecasted environmental metrics. This is particularly useful for planning. If you need to run an energy-intensive workload, and you can see that tomorrow morning your region will have a lower carbon footprint, perhaps because strong winds are forecast overnight, you can schedule your job for that window and reduce your environmental impact without any extra effort. Let's close with a practical example. Imagine you need to run a large computation, and you have access to computing resources in 2 different European locations, say one in Poland and one in France. Looking at the carbon footprint map, you will almost always see that France has a significantly lower carbon intensity than Poland. France generates a large share of its electricity from nuclear power, which has very low life cycle carbon emissions. Poland, on the other hand, still relies heavily on coal. So from a carbon perspective, France is clearly the better choice, but let's not stop there. Now let's switch to water impact. Here the picture can look quite different. Water impact depends not just on how much water is used, but on regional and seasonal scarcity. Southern and Mediterranean regions can show higher water stress during summer months, while northern regions tend to show very low impact year-round due to abundant freshwater availability. So, depending on the time of year, the water impact picture may reinforce or nuance what we saw with carbon. This is exactly where the green score becomes useful. Instead of switching back and forth between metrics and trying to weigh them mentally, it combines both the carbon operational footprint and the water operational impact into a single comparable index. With green score selected, you can compare France and Poland and any other available site at a glance, getting a single answer to the question, which location is the most environmentally friendly choice right now to run my workload? And with the forecast view, you can extend that comparison into the next 72 hours, helping you decide not just where, but also when to run your workload for the lowest possible environmental impact. That covers the main features of the Wattnet dashboard. To summarize, You can explore real-time and historical carbon and water footprint data across European power grid zones, switch between metrics, dimensions, and scopes, enable flow tracing to see the true consumption-based footprint, and inspect individual cross-border exchanges, animate the map over time, analyze trends in the zone detail panel, and plan ahead using the 72-hour forecast. This dashboard is developed by the IFCA Advanced Computing and E-Science Group at the Institute of Physics of Cantabria, a joint center between the Spanish National Research Council, CSIC, and the University of Cantabria. This work was carried out within the GreenDIGIT project, funded by the European Union's Horizon Europe Research and Innovation Programme and by the Swiss State Secretariat for Education, Research and Innovation. The dashboard is freely available at dashboard.wattnet.eu. Open it, explore your region, and start understanding the environmental footprint of your electricity consumption today.